Hello, everyone, and welcome to a new video on statistics. So let me remind you of what we did so far. So we talked a little bit about how to sample data. We talked about the sampling techniques, and then we moved to, we talked a little bit about probability before that. I had a video about that I posted about probability. Usually when you do statistics, there's a probability involved in the discussion of statistics, but the way we are doing it here at Valencia, it's a little bit, simple for this course. So when you take a statistics course, then you will be introduced to statistics after you have a thorough discussion of probability. Anyway, so we talked about, like I said, sampling techniques, and then we moved to talking about the middle of data. I mean, if you have an idea, if you would like to form an idea about the middle of the data, then you have different types of averages. You can have the mean, you can have the mode, you can have the median. And those actually will, like I said, will give you an idea about the center of the data. But the center of the data is not always a very, I would say, sufficient. It's not a sufficient piece of information, because I can give you an example. Suppose I have, just to simplify things, to have an idea about how things can go, I would say misused again. If I say I'm teaching two classes of the same course, let's say liberal arts 1, that's first section, and liberal arts 2 of the same course. And it happens that in these two sections, I have two students in each of those two sections. And I gave a test. I gave the same test to both of these sections. In the first section, one student got 99, a near perfect score. Another student got really a poor score. That student scored 1 out of 100. So what would be the average? What would be the mean of this class? Well, 99 plus 1 divided by 2, which is 100 divided by 2, which is 50. So 50 would be the mean score of the first section. However, in the other section, the two students in the other section, one of them scored, let's say, 51 out of 100, not so great. And the other student scored 49 out of 100, still not a good grade. So let's do the mean. Let's do the average, the usual average, which is the mean. Add 51 to 49, which is 100, divide by 2, which is 50. So it looks like if I give this information to somebody who was not exposed to statistics, I says, well, I have two sections, the average score in both of them was 50. Probably that person, very highly probable that this person would say, oh, both of these sections are actually doing pretty much the same, or in terms of performance, which is totally unfair to that student who scored 99 out of 100. So what I'm trying to say through this example is that the average, it's not the mean, it's not always a good information. So the first section, those two scores were really spread out. There's a big jump or a big gap between 99 out of 100 and 1 out of 100. However, the second section, the two scores are close to each other. Well, luckily in statistics, there is a measure of the dispersion of the data. And it's called, one of them is called the standard deviation. So in this video, I'll be talking about the standard deviation. And the good news is you can use the calculator to calculate that standard deviation instead of doing it by hand. And just to show you how doing things by hand can be really daunting, I have an example. But of course, we're not going to do it by hand. There's software. You just go Google and put standard deviation calculator, or use your calculator, TI-84A3. In fact, I have a link on courses on Canvas that shows you how to do all these statistics: the mean, the mode, the interquartile. I think that it doesn't give you the interquartile range, but it gives you the Q1, the Q2, which is the median, and Q3, and so forth, give you the minimum, maximum, standard deviation. So I put that link in that module of chapter number 12, the last module. So please go ahead and check it out. All right. So again, we'll be talking about the measures of dispersion. So you will learn how to calculate the range of a set of data that something I didn't mention before, but the range means the range simply is the distance between the very lowest number and the very highest number. And then, like I said, we'll be talking about how to calculate or how to do or to calculate or to measure the dispersion using what's called the standard deviation of data. Well, measure of dispersion are used to measure the variability of data. And that includes, of course, the spread of data. So what is the range? Well, simply, like I said, is just the highest value minus the lowest value. So to take the highest value, if you are, let's say, collecting ages, so take the highest age, the older person, the age of the older person minus the age of the youngest person, and there you have the range. It gives you an idea about the variability or the spread of the data. In the example I gave you before I start writing the slides, 99 minus 1, which is 98, will be the range of the first class, the first section, and 51 minus 49 would be 2. So as you can see that the first section, the range is much higher than the second. Well, if you are given numbers like this, so they are, like you say, not necessarily sorted, but you just need to spot the highest number and you minus the lowest number. And in this example, these numbers represent the amount of carbohydrates in grams of 10 different types of yogurts. And so you can see solution simply really is the highest number is 29 minus the lowest one is 8. So 21 is the difference between the most or the highest carbohydrate yogurt and the lowest carbohydrates yogurt. Well, the standard deviation. This is the formula of the standard deviation. It's kind of like too mathy, scary, right? So to calculate the standard deviation is the square root. This symbol called sigma is a summation. It means you got to take, first of all, if you recall this x bar is the mean. And then you can calculate this by adding all the numbers and divide everything, divide that sum by the number of numbers that you have. That's called the mean, or that's called the average as we know it outside of the classroom, right? And then you need to go and take every single piece of data and subtract the mean and square it. Go do it again. And then add up all these things at the end, subtract or divide everything by n minus 1. And what is n is the size of your sample, is the size of how many numbers you have. Let's say if you collected 20 ages, then n would be 20. And doing this by hand is really time consuming, and there is a high chance that you are going to mess up with the calculation. But luckily we have software, we have technology. Your calculator can do this really in no time. So the steps, again, if you do this by hand, which is not recommended, determine the mean of the set of data, like we did in the previous slides, and then take each piece of data and subtract the mean and square. So you take the data, you subtract from the mean, and whatever you get, you square it. And you do this for every single age, for every single score, for every single number that you collected. And then you don't have to list anything vertically, then add up all those squares and subtract everything, and divide everything by n minus 1, and then take the square root of that. So subtract the mean from each piece of data, like I said, place the difference in data minus mean column, if you want to do this in columns, and then you square things, and put that in another column. So it's very, very lengthy, and divide everything by n minus 1, and then take the square root at the end, which is the last step, step 8 here. Well, not really fun. So suppose we're going to do this by hand. So just to give you an idea, so we can appreciate those calculators, so we cannot just take them for granted. So some people did the hard work for us. So how are we going to find the standard deviation of all these numbers? Well, these are the data: $17, $28, $32, and so forth, all the way 104. So first of all, get the average, get the X bar. What is X bar? Is 17 plus 28 plus 32 plus 36 plus 50 plus 52 plus 66 plus 74 plus 104, and divide that by how many numbers we have. How many numbers you have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide the sum, divide by 9. That's what they did here. So, and you get 51. So 51 is the mean of those numbers. That's step number 1. And then this is the bar. For each, you see the 17, 28, 32, all the way 104. Those are the numbers given to us in the exercise. And then take each number and subtract that from 51. So 17 minus 51 is 34 or negative 34. By the way, it doesn't matter which one. You can put x bar minus x or x minus bar because you are going to square it. And we know when you square negative 3 squared is the same thing as 3 squared. So negative 3, everything squared is the same thing as 3 squared. So it doesn't matter which one you do first. So once you get all these differences set up, then you need to square them. 34 squared is 1156. Like you see here, negative 1 squared is 1, 15 squared is 225, and so forth. And then you add up all those squares, right? And this is the sum of the squares. And then you divide that by n minus 1. And n here is the number of numbers, which is 9. So you divide everything by 8. So that's the number we got, the sum, and divide this by 8. And you took the square of everything. And 27.01 is the standard deviation. And what does this mean, really? 27 means that the average distance between each piece of data obtained and the average is 27 points, $27 in this case here. So the standard deviation to the nearest tenth, of course, if you round this to the nearest tenth, would be 27.01. That's what it is, really. And then, of course, it's up to people to interpret this. So if I am comparing two collections of data or two, let's say, populations on the same context, like say two classes given the same test, let's say two cities or two companies, and I'm doing with the same, doing the let's say salaries or so forth. If one distribution or one population has a bigger standard deviation than the other, means that the data, the numbers in that company are more spread out than the first one. So the smaller the standard deviation means what? Means that those numbers are and closer to each other and closer all to the mean. That's the meaning of the standard deviation. Well, again, it's up to people to interpret things. So statistics will, a set of tools that will give you how to calculate the mean, the average, the range, the interquartile range, and so forth. And it's up to the consumer to, to make interpretation of the data. I hope this is clear to you. Well, if not, please, of course, you need to let me know. I'm just an email, phone call, text away. Just please let me know.